Good morning, students. Now we will deal with the third module. This module consists of beams. See, this deals with beams. What are the different types of beams we have to discuss? What are the different types of loading on beams? Now we have to study what is the concept of bending moment and shear force, relationship between intensity of load, shear force and bending moment. How to draw shear force and bending moment diagrams of different types of beams like cantilever beams, simply supported beams and overhang beams for different types of loads, and we have to see what is the term meaning of point of contraflexion and how we will locate the point of contraflexion. So these are the things we are dealing in this module 3. So all of you know that we come across various structures in our day-to-day life, ranging from simple structures like the curtain rods and electric poles to complex ones like multi-story buildings, shell roofs, bridges, dams, heavy machineries, automobiles, aeroplanes, and ships. These are known as structures, and these structures are subjected to various loads like concentrated loads, uniformly distributed loads, uniformly varying loads, random loads, internal and external pressures, and dynamic forces. So the structure transfers its load to the supports and ultimately to the ground. Treating the entire structure as a single rigid body and finding the reactions from supports is the first step in analyzing a structure. That is, we have to treat the entire structure as a single body and we have to find out what are the reactions from the supports. So this you have studied in engineering mechanics, how to find out the support reactions. So while transferring the loads acting on the structures, the members of the structure, they are known as the structural elements like beams, columns, trusses, etc. These are subjected to internal forces like axial forces, shear forces, bending moments, and torsional moments. So the analysis of these internal forces in the members of the structures, that is finding out the magnitude and direction of these forces, is known as structural analysis. So we have to find out the forces which are subjected to these structural elements, and structural design deals with sizing the various elements of the structure to resist the internal forces which they are subjected to in the course of their life cycle. So the process of finding the reactions, internal forces, behavior of materials of structures to such forces, and sizing of the members are interconnected. Okay. So first we will see what is a beam. A beam is a structural member that resists external loads by bending. And as a result of this bending, there will be development of an internal force resultant called bending moment. So when a beam is subjected to external loads, the beam will bend, and as a result of this bending, there will be an internal force resultant, and this internal force resultant is called bending moment. So how the load is acting on a beam? Usually in a beam, the load acts in the form of direct forces applied perpendicular to the longitudinal axis of the beam. So the presence of the intermediate loads between the supports on a beam, or this will result in a difference in bending moment, And as a result of the difference in bending moment at the two ends of the beam, this induces a second internal force resultant called shear force, and it is represented by the letter F. And this causes the bending moment to vary across the length of the beam. Okay. So due to the difference in load, there will be difference in shear force, and as a result of the difference in shear force across the beam, there will be variation in the bending moment along the length of the beam. Now we'll see what are the different types of beams. The beams can be classified as cantilever beam, simply supported beam, fixed beam, and continuous beam. Cantilever beam means a beam which is fixed at one end and free at the other end. Fixed at one end and free at the other end. Now a simply supported beam means a beam which is hinged at one end and simply supported or with a roller support at the other end. This is known as a simply supported beam. Fixed beam means a beam which is fixed at both ends is known as a fixed beam. A continuous beam is a beam having more than two supports like this. 1, 2, 3. This is known as a continuous beam. So the beams are classified based on the supports. So what are the different types of supports? Fixed or built-in support. So this is an example of a fixed or a built-in support. So usually the movements allowed are in the horizontal direction, in the vertical direction. These two are translations, and a rotation in the clockwise or anti-clockwise direction. So in the case of a fixed or built-in support, all the 3 degrees of freedom are arrested. That is, there is no translation or rotation. No translation or rotation is possible in the case of a fixed beam. Example is a beam column joint, which is of a reinforced concrete beam column joint, and also a welded beam column joint in the case of a steel structure. Now second type of support is a hinged or a pinned support. So this is an example of a hinged or a pinned support. So here the translational degrees of freedom are arrested, but rotation of the connecting member can occur freely. So here this is allowed to rotate, but this is not allowed to move in the horizontal direction and also in the vertical direction. So degree of freedom is 1. That is, rotation is allowed. All other degrees of freedom are arrested. Now the third type of support is a roller support. So in the case of a roller support, the translational degree of freedom is arrested in one direction. That is, normal to the plane of the roller. It is not allowed to move. That is, it is not allowed to move in the vertical direction, but it can move horizontally and also it can rotate. So freedom to translate freely along the plane of the roller direction, and also for the connecting members to rotate freely. So this is allowed to rotate, and also this is allowed to move in the horizontal direction. So whenever there is a restriction in movement, there will be reactions. So in the case of a fixed support, since all the 3 movements are restricted, there will be reaction in horizontal direction, reaction in vertical direction, and also there will be reaction to the rotation. So there will be vertical reaction, horizontal reaction, and a moment will develop at a fixed support in order to resist the movement in horizontal, vertical, and rotational movement. So number of unknown reactions in the case of a fixed support is 3. Now in the case of a hinge or roller, the movements restricted are in the horizontal direction and in the vertical direction. This is allowed to rotate. So there will be 2 reactions, and the reactions will be along the horizontal direction and in the vertical direction. So there will be a horizontal reaction and a vertical unknown reaction. Now the third one is a roller support. Here the roller is not allowed to move in the vertical direction. So there will be only one unknown reaction, that is in the vertical, direction, that is the vertical reaction. Okay. Okay, now we'll see in detail what is the meaning of statically determinate beams? So first one is a cantilever beam. So what is the meaning of a cantilever beam? It is the simplest externally stable structure characterized by fixity condition at one end and free condition at the other end. So here, when the cantilever is subjected to applied loads, there will be three support reactions. Three components of support reaction can be developed at the support. They are, it will be VA, vertical reaction, HA and MA. Okay, corresponding to the three restraints provided. That it is, this support will not allow movement in the X direction, movement in the Y direction, and also the rotation is prevented. So there will be three reactions against the three restraints. So if there is no horizontal load or no inclined load, this horizontal component of the reaction will be 0. Okay, so here in the cantilever beam there are three support reactions: reaction in the vertical direction, reaction in the horizontal direction, and a moment. So being you have three unknowns and you have three equations of equilibrium. What are the three equations of equilibrium? Sum of the horizontal forces is equal to 0, sum of the vertical forces is equal to 0, and the algebraic sum of moment in all direction equal to 0. Okay, so we have three equations of equilibrium and three unknowns. So this cantilever is a statically determinate beam, which implies that the support reactions and the internal force resultants along the length of the cantilever, that is, what are the internal force resultant? Axial force, shear force and bending moment can be determined, and this beam is known as statically determinable beam, or it is statically determinate beam. So we can apply the equations of static equilibrium to find out the unknown forces and the internal reactions of the beam. So a cantilever beam is statically determinate because we can find out all the internal reactions and the external reactions, internal force resultant and also the support reactions, by using the three equations of equilibrium. So another arrangement or another beam is a simply supported beam, which involves two supports which together resist the displacements, that is the displacement in horizontal and vertical direction and also the rotation. So one of the supports is hinged support, which restrains horizontal direction movement, vertical directional movement and also rotation, and the second one is a roller support, which resists the movement in the vertical direction. So this support condition, this a planar structure with such support condition is called a simply supported beam, and here you have three unknowns, HA and VA at the support A and VB at the support B. You have three equations of equilibrium, so this beam is a statically determinate beam. Simply supported beam is a statically determinate beam. Next type of beam is a simply supported beam with overhang. So in some cases the structure may protrude beyond one or both knife-edge supports. The extended portion is termed as an overhang. So here you have a pinned or hinge support, here you have a roller support. So for this support you have two unknowns, and for roller support one unknown. So total number of unknown reactions is 3 and number of equations of equilibrium is 3. So this is a statically determinate beam. So we have studied about what are the different types of supports and what are the different types of beams. We have studied about statically determinate beams and how to find out the static indeterminacy. Thank you.